Attendees are in listen-only mode.
On behalf of the National Pollution Prevention Roundtable, welcome and thanks for joining this Life Cycle Assessment webinar as part of the Safer Chemistry Challenge Program webinar series. My name is Cindy McComas, and I'm an adjunct professor at the University of Minnesota, in addition to working as a project manager with the National P2 Roundtable. We've designed this webinar series to provide you with information and resources that will help you advance your efforts towards safer chemistries using source reduction strategies as part of your business sustainability programs. This webinar series fits with the goal of the Safer Chemistry Challenge program to motivate, challenge, assist, and reward companies as you find safer alternatives to chemicals of concern to human health and the environment. The Challenge program is a unique partnership between industry, states, and nonprofits. It can accelerate opportunities for you to capture emerging markets for products with safer chemistries, and it results in a cleaner environment while providing value to your company's bottom line. This webinar is the second in the series, and we have a number of other webinars scheduled. So you can see we're on the March 7th webinar. Our next one is April 3rd, Introduction to Green Screen, and we hope you'll join us for that. I have a few logistics to cover. During the webinar, all attendees will be on mute. If you have questions, please submit them through the Submit Question option in the toolbar that GoToWebinar provides. If there is time, questions will be answered at the end of the webinar. We would very much like to hear from you on how you think this webinar helps meet your company's program needs to move towards safer chemistries. At the end of the webinar, you'll receive a survey, so please be sure to fill that out and provide us with your feedback. It's now time to introduce our webinar for today. It's called Tools to Measure Sustainability Life Cycle Assessment. There will be two speakers. First is Dr. Anahita Williamson, who's the director of the New York State Pollution Prevention Institute at the Rochester Institute of Technology. Dr. Williamson has extensive experience in utilizing life cycle assessment methodology for evaluating environmental performance of a process or product over its entire life cycle, and she has performed multiple LCAs throughout her career. She's also a Lean Six Sigma certified Green Belt. She holds a BS in chemical engineering and an MS and PhD in civil and environmental engineering, all from Clarkson University. Our second speaker is Kate Winnebeck. She's a senior environmental health and safety specialist also at the New York State P2 Institute at the Rochester Institute of Technology. Kate assists companies with product stewardship and reductions in toxic chemical use initiatives, including green product assessments and life cycle assessments. Through RIT's affiliated Center for Integrated Manufacturing Studies, Kate performs safety risk assessments and training for manufacturers to develop sustainable, effective safety management teams to reduce the use of toxic and hazardous materials and to promote a safe work environment. Kate has a BS in Environmental Management and Technology and an MS in Environmental Health and Safety Management, both from RIT, and she's a Life Cycle Assessment Certified Professional. So now it's time to begin the webinar with Dr. Anahita Williamson.
Okay, so thank you for having us and hosting us, NPPR. And again, welcome. My name is Anahita Williamson. So I'll be starting this off. Just on a very high level, I wanted to at least let you know a little bit about the New York State Pollution Prevention Institute at RIT. We have funding from the state to be a technical resource for industries, for academia, and for not-for-profits. We have an overall goal and mission to reduce the environmental footprint in New York State. So it's a broad mission. It's a big state, but we have a lot of partnerships to help carry this out. We're partnered with 3 other universities, Clarkson, University at Buffalo, and RPI. So we do have a research and development arm to continue to develop innovative new solutions in the field of green engineering, pollution prevention, and sustainability that we can then disseminate and implement into New York State industries. We have a direct client assistance program where we're partnered with 10 manufacturing extended partnerships located throughout our state. And we're really boots on the ground. We have our engineers working in collaboration with industries to, again, be able to reduce their environmental footprint by reducing their costs. So we have a very unique opportunity to not focus on compliance and regulations and permits, but to really be able to look further upstream in a process and look at true pollution prevention and green engineering type solutions. We also have a community grants program, so we do offer both financial and technical support to not-for-profits located throughout the state. And I think one of the reasons we really enjoy our job, at least I do, is the fact that we get a chance to touch academia, industry, and not-for-profit. So it's really kind of addressing that triple bottom line to sustainability. We also put on workshops and trainings such as this one. We're excited to talk to you about life cycle assessment today. And finally, we have sector projects. And I know Kate could do an entire webinar on hers, which is focused on dry cleaners in New York State, being a major sector where we could actually have a major impact if we could potentially move them away from utilizing perchloroethylene to maybe a more environmentally friendly technology. So that's a different subject. So let's get started. With life cycle assessment, what Kate and I wanted to do today was really give you an introduction to the tool. It is a very complex process, and there's a lot of detail that we could get into. So I consider this more of a phase 1 background introductory type webinar. And if there was interest to go into that next level of detail, it's something that we could provide at a future time. Sorry, I'm clicking here. Give me 1 minute. Okay. Okay, so what is life cycle assessment? It's really a tool that you can utilize effectively to quantify the environmental impact of a process or a product from the raw material phase all the way through its end of life. So really a true environmental analysis of a cradle-to-grave process or product. And as you can see in the diagram here, everything from where raw materials are extracted from the earth through their processing, through their manufacturing, through their transportation, from the raw materials to the suppliers, from the suppliers to the manufacturing, and all the way down through the distribution and use. Of course, we include use and then the end of life. And we've actually had more and more interest from companies in looking at their end of life and where does their product go? Does it go to the landfill at the end of the day? Incineration? Can you reuse it or recycle it in some capacity? And all of that is analyzed within the life cycle. I think the objective really is to evaluate the environmental burdens associated with a process or product or an activity by identifying and quantifying, and we'll get into the inventory stage of that, energy and material usage and environmental releases, and then being able to take those releases and turn them into impacts and assess the impacts of the releases, and then at the end of the day to make improvements, and that's really what we want to be able to do. There's 4 main steps to a life cycle assessment. The first one is really the goal and scoping. So this is actually one of the most important steps in the process, and depending on who is doing the LCA, whether it's a team, it's very important to have this discussion up front. It is a very critical step in defining your boundaries, and we'll talk about it some more as we walk through an example. But once you do define your boundaries and your scope, the next step is a life cycle inventory, and this is really where there's a lot of data that's involved. It's very data intensive. It's performing detailed mass and energy balances around the process. With inventory, this is something that could be done by hand, especially if you're working for an institution where you can go out and actually collect the data. But also, we now have software, such as SEMA Pro, which Kate will be talking to you about, where a lot of data and all the analysis that has been done has been put into a package that we can utilize to make the process a lot more efficient. But then from there, there's impact analysis, and that's really where SEMA Pro or Gabby and these LCA software tools have their biggest impact, is to be able to take the results from the inventory, so where you find out your inputs and outputs, how much water you're using, how much toxics are there with the energy use, and then be able to actually translate that into environmental impacts such as climate change and land use, fossil fuels, carcinogens, ecotoxicity. These are all examples of what you can get from the impact stage. And then finally, there's the reporting results, but really the improvement. So why did you really do this LCA? And we'll get into some of the benefits and some of the challenges of that. Okay, so there are standards, fortunately. And I think, as LCA became more and more of a popular tool, it only made sense to have and develop an ISO standard. So this is one that we hold closely here and abide by. These are internationally accepted standards for performing life cycle assessment, and they do give you guidance for all the stages that we just discussed. One of the parts of this is also the critical review, and that's something that we also do at the Institute. So if a company was to do a life cycle assessment and they wanted to publish it, it does go through a critical review or a peer review process. And if, for instance, at our organization, if we do the LCA, we send it out for peer review as part of the process. But by critical review, it's really completed by an external expert, and they are looking at ensuring that the methods used to perform the LCA are consistent, they're scientifically sound and technically valid, and that really the appropriate data was utilized in order to reach the goals of the study, and overall the report is transparent and consistent. Also, as Cindy had mentioned in introducing Kate, we have Kate Winnebeck and Brian Hilton, who are certified professionals in the life cycle assessment certification, which is relatively new. And there are, we listed the website here, so if you're interested in finding out how to get the certification, you can go to that. There are some prerequisites that need to be met. For instance, a degree in, you need to have an undergraduate degree, you need to have some experience with life cycle assessment, but at the end of the day, you do have to take the test and really show that you've had enough experience to be a certified professional. So why should you use LCA? We have a whole list here, but of all the companies that have approached us recently, I think a couple key points stick out. One is that there's a lot of interest in designing for the environment in the next future stage of products. In order to understand where to go, you really need to understand your baseline, and not just by drawing your box around the toner I'm sorry, I'm so stuck on my example. Not just drawing your boundaries around a manufacturing process of any sort, but to really be able to expand it to the life cycle and understand the baseline over the whole life cycle, so you really understand where you have opportunities to make improvements for future design. So that whole, almost for an internal standpoint, it's very effective when it comes to designing for the future. Also, we've had a lot of companies interested in trying to tell the story about their product, that, for instance, that they've developed this new green product. Well, what does that really mean? And there's a lot of concern out there right now with greenwashing. So to be able to quantify exactly what you're talking about when you're selling or marketing your product as being more environmentally friendly, this is one of the best tools you can use currently today. So, and I'll let you read, the other great reasons to use LCA, but those are some of the core reasons we see. There are, three methods really to conduct the LCA. Obviously, there's the manual method, which is very tedious and very data intensive, and also very accurate at times. I mean, if you're out on the plant collecting the data yourself, you know that it is the reality of the situation. One of the challenges with LCA is that you do have to make assumptions when you don't have the data or when you're performing the data in collaboration with someone else. So one of the key points is to always state your assumptions, to always ensure that you're documenting why you're decided to make certain estimates and so on. There's also software. Of course, we'll talk about that because it is very useful. But again, the assumptions that go along with the choices you make in the software are critical. And then, of course, a consultant is always an option. I think as I start to get into the example that I'll be showing you today, one of the main points I do want to get across is how important it is to not always focus on just the box that you're in. So if you're in the supply chain and you're a supplier, typically you're just focused on optimizing your little box. If you're in the manufacturing process, typically your box is the process and you're trying to always optimize that. In the example I'm going to go over today, it was work that I did actually as a graduate student with a Xerographic company, and when we had started working with them, the manufacturing plant was very interested in optimizing their box, the manufacturing process. But what you'll find out is at the end of the results, even if we had poured money and time and resources into the manufacturing process, it wouldn't have had much of an impact on the entire life cycle. So this was a great learning opportunity for us as doing the LCA, but also for the company in realizing the value of the results. Okay, let's get started on this example. Just to put it into context, I'm going to be talking about toner. Toner is not something that you always see every day, so this is just to put it into context. Fortunately or unfortunately, I know more about xerography than one perhaps should, but this is the xerographic process. It's numbered for your convenience. The first step is charging of the belt. You can use lasers or light from the past in order to expose the image onto the belt. And then step 3 is really where I'm talking about. This is where there's toner and carrier. This is really the black powder you get on your hands when you're playing around with your copier, and in this case it's actually being charged so that it actually produces an image onto the belt. And then of course you have paper that comes in, it also has a charge, and then the toner is able to stick to the paper and it goes through a fusing process. This could be a whole seminar by itself, but the bottom line is that we're talking about the toner piece of xerography here. Okay, so again, to go back through the phase of starting to do an LCA, in this case, the first question is why? And as I mentioned, you know, we had an opportunity to optimize the manufacturing process for toner. So as an opportunity here, we said, well, let's really look at the baseline of the entire process from cradle to grave and really see where there's environmental opportunities before we just put all our resources and time into manufacturing. So we defined the goal and the why, and we brought together our team, and then we defined the scope. Now again, with the scope, not just for this example, but in general, it is such a critical step. You really want to consider what materials, processes, products are you going to be considering, how broadly will you be defining the scope, and a lot of that you have to take into account some considerations. For instance, who's going to be performing the analysis? In this case, we were, so we were actually able to go into the manufacturing process and quantify the material inputs and outputs. A lot of plants have their energy bills, they have 1 meter, and they have 1 meter for water, but no one's really gone in and actually done the detailed mass and energy balances. So that was something that we could do and collect that real-time data. Also, you know, what kind of resources you have to actually do this study, what kind of timeline, these are all important things to take into consideration. And what you really want to find out is what is the most limited scope of analysis that you can have that still provides adequate consideration of the systems aspect. So like, for instance, you know, how much can you really put in from a time and effort and resource standpoint, but not go beyond and over and have a 5-year LCA. I mean, at the end of the day, you want to get to your results. So you really need to figure that out as a team. And of course, in this stage, defining your functional unit is critical. So what is that unit that you're going to be carrying throughout the entire life cycle? So in this case, this is the toner manufacturing process. This one big box with all these different steps is what it entails. And this, at the time, this company had already done a lot internally. They had internal recycle loops and external recycle loops. So already they had done a lot to reduce their environmental footprint. We picked the functional unit of 1 metric ton of toner produced, so 1,000 kilograms, and then we considered, you know, all aspects of the scope. So what I wanted to show you here is the bigger picture. So now this is the toner manufacturing process that we just saw on the previous slide. There's 3 main components that make up this toner process: carbon black, resin, and magnetite. So now you've got to take it back all the way to the raw materials extraction. So these are the 3 core. But now you have toner. When you are done with manufacturing that toner, it has to get to the customer. So there's transportation there, and the customer actually uses it in their xerography process. And at the end of the day, the toner has to go somewhere at the end of life. So this is the big picture defining the boundaries. This is kind of where you're going with your scope. Let's take that one step further. Now, I didn't highlight the toner manufacturing box, but hopefully you can find it right in the middle of the screen. And then again, if you just take a look at those 3 arrows, again, you have that resin, production, carbon black, and magnetite. But resin doesn't come from the earth, right? Resin, in this case, was made up of butadiene and styrene. And each of those were, again, going back all the way back to the earth is ethylene production and then the extraction of ethane from the earth. So we're really not kidding when we're talking about raw material extraction. It's taking each of the components that make up your process, and the best thing to do is a process flow diagram, as I'm showing you here. To get it all down on a picture, to be able to follow the process through its life cycle is critical. Again, let's now look at the end of life. So now you've manufactured toner, it goes to the consumer, and it also goes to the end of pipe in some capacity. So looking at the post-production processing, again, just drawing it out so to make it as visual as possible. So from toner manufacturing, in this case, it went to the customer, it got used in the machine. The machine itself, from there, when it was considered waste, it could either go to, well, let me back up here. When you're using it in the machine, the toner itself can go on paper. Now that paper can either get filed, you might file it forever, or it can go into the solid waste management, or it can get recycled, which is what we hope, and then there's de-inking that occurs. So that's one path. and then there's a couple others as well that you can follow. So once it's being used in the machine, again, the toner can go and you can just dump it when you are changing your cartridge, or it can actually get recycled and go back to the manufacturing process. So again, I'm showing you these visuals because it's very important to map out your process to understand all avenues, and not only at the beginning, but at the end of life. It's just as critical. Okay, step 2. Now you've gone through your scoping, your boundaries, you've mapped out your process. Now it's time to do math, or use SEMA-Pro, but we'll get there. So this is life cycle inventory, and the work that I'm showing here is published in the Journal of Cleaner Production, so you can see all the nitty-gritty details if you're interested. But the bottom line is it is highly data intensive. If you have access to data or can measure it at any point, it's very highly recommended to do so. But there are challenges because, as you all know, not all data is easily accessible. And even as we work with manufacturers that have a lot of suppliers, they're not always that easy giving up their data. So there are assumptions that do have to be made, and there's been a lot of data put into the software packages that you have options to choose from. So you can certainly work around it, but this is just some of the challenges. Again, very detailed mass and energy balances going through the process. And what's shown on the bottom left here is actually an output from SEMA-Pro. So what the software will show you right away when you run your analysis is those thicker red lines show you where there's more of an impact. So right away you can kind of zone into, well, here, what's going on here in this process? Why is it causing a higher level of impact? And again, with the inventory, again, just to make sure it's clear, we have to really consider what should really be involved. And sometimes people have asked, and we've talked about here, what kind of a rule is there? Is there any kind of rule as far as what you can put in? If you have a really small part or component, you have to include it. Like how much of a level of detail do you need to get into? Now, some books have said there's a 5% rule, so that if there's a material or a component that is comprised of less than 5% by weight of product, then you can neglect it. However, there is an amendment to that rule in the sense that if you are working with something that is highly, for instance, toxic or hazardous, and it is less than 5%, you still need to include it. So there are some rules, but there are other considerations to take into place. Okay, so this is just to show you some of the results from our study, specifically with the toner. And again, this is the data that would come out of the inventory. Right off the bat, just to give you an idea, up at the top here, if you can see my arrow, you have the different types of environmental media. So you have your energy, you have your air emissions, your particulates, the wastewater, the solid waste. And then down on the y-axis, you have all the different steps in the life cycle, from the raw materials of carbon black, magnetite, and resin, through toner manufacturing, consumer use, end of life, and transportation. If you look at the numbers right off the bat, you can see for energy, the consumer use is significantly high. So if you compare the energy use to the rest of the life cycle, it's evident that consumer use plays a lot. So the fact that the toner is in the xerography process, it's something to consider as you're thinking about future designs. Maybe considering to make a toner that consumes less energy in the machine is a direction you want to take in the future, and that was actually considered and done. Again, what was one of the most surprising things here was the end-of-use processing. If you're looking at wastewater and solid waste, it's not going on in the toner manufacturing process. It's minimal compared to end-of-use processing. And I think this was one of the biggest surprises that we had, because as you're taking that toner and it goes onto the paper, when you have to recycle it, you are actually de-inking the toner from the paper, and it's a very chemical-intensive process that does create a lot of wastewater and solid waste as compared to the rest of the life cycle. So as we talk about the future, again, of toner, and there's a lot of discussion around bio, soy-based type toners, they're trying to some extent design them so it has less of an impact on the end of life. Now all those numbers, I'm running out of time here, if you take those numbers and just plot them, it's a very easy visual to see. So here again you have all the different environmental media on the y-axis. I'm sorry, let me back up one or two. And then over on the right-hand side you can see the scale, and each of the life cycle stages you can tell by their design. So right off the bat, you can see the consumer use actually is a major part of the life cycle, and so is end-of-use processing. Now, if you remember from this example, we had originally gotten involved to focus on toner manufacturing, which is the diagonal. But if you look at this plot, it's evident that the toner manufacturing process itself is actually minimal when it comes to the environmental footprint as compared to everything else. So this was used in a couple ways, and I'll wait to talk about that. But from the inventory stage at that time, this is where we stopped. And I just want to show the value of the mass and energy balances, even before taking it to that next level of how do these numbers have an impact on land use and fossil fuels. There's a lot of value in just the output of the mass and energy balance and the raw data. I'll turn it back over to Kate.
Okay, so the next step in this is really the impact assessment, right? So you're taking the inventory and actually converting it into impact. It's great that we know how many pounds of CO2 emissions we have, but how can we translate that into some actual effect on the environment? You know, can we say that that's going to affect some species, or it's going to cause, you know, so many human health issues, et cetera? And that's what the impact assessment does. So there are a lot of different impact assessment methods out there. Again, we're not going to get into exactly what those are, but there's a lot of different ones. They definitely vary in their methodologies because you can apply weights to impact categories. So let's say, you know, for example, human health is very important to you. It's more important than ecotox for whatever reason, right? You can apply those kind of value judgments to the data, and you can then weight the human health effects higher than the ecotox data, if that's, you know, something you want to do. So this slide here shows kind of all the background that goes on in the impact assessment. And again, these are usually done in software because it is so complex. You know, it's relatively simple to collect inventory data, you know, as Anahita showed. But then if you were to manually do that, to kind of go through the steps here would really be kind of a bear or a burden to do. So the way most of the impact assessment methods work is really they take that life cycle inventory, and then there's a fate analysis. So the fate analysis looks at the properties of that substance, so that substance in your inventory, and determine where it will end up, right? So is it more likely to end up in air, water, soil, a mix, you know, depending on really the properties of that substance. So the result of that fate analysis is a concentration of a substance in those media, in air, water, soil. It could be food as well. So that's kind of the impact category column, right? That's the concentration of things. Then you have this exposure and effect analysis. So the exposure analysis really looks at how much of the substance then, so now we know how much the substance is in air, for example, but how much of that is actually going to be taken in either by people or by the environment. So how much is actually going to be kind of absorbed, if you will. And then the effect analysis predicts what those effects will be, so those category indicators, based on the amount that's taken in the exposure analysis. Okay? Then we have the damage analysis. So really, you're taking those same effects, those category indicators, if you will, and you're translating them into one unit. Okay, so now you're trying to find a way, how can I take you know, respiratory effects, carcinogens, non-carcinogens, how can I bucket those and call them human health? So it transfers or translates, for example, human health into dailies, this disability adjusted life years. That's what's typically used. You know, same thing for ecosystem quality. There's a unit for that and resources as well. And then after that stage, you can further normalize, you can weight that data to get a single score indicator. Okay? So the next slide here, and this is an example of an impact assessment method. This is Eco Indicator 99, which is somewhat outdated right now. There's been some newer impact assessment methods, but it's still, you know, commonly used. But you can see how the impact assessment method itself, how it takes those different impact categories, category indicators, and how it kind of assigns them. So you might see, for example, let's see if there's one in here. Like some things will actually go land use and land conversion, right? So that actually goes to two different indicators. So you don't necessarily have kind of this linear flow. It can kind of be, it can flow in different directions. And again, it depends on the impact assessment method and how kind of the method is developed. And all these methods, of course, are developed by panels and groups of international experts and scientists. So they've all kind of been internationally accepted as well. So since Anahita's toner example is actually built into the databases that we have available, I was able to run the impact assessment and actually see, okay, well, what spits out? What's the environmental impact of toner? Where are kind of the major factors? What are not as important, et cetera? So you see non-renewable energy, global warming, respiratory inorganics, and carcinogens kind of jump out, and you can definitely see some of them, fall down below. So you can then take these results and decide, okay, are we going to go after non-renewable energy? Is that something that we want to work on reducing? Or maybe before this, you really were looking at ozone layer depletion and respiratory organics. Well, you run the assessment and go, well, these aren't that important to us. Why are we focusing our efforts on those areas? It can really be used to help you kind of guide where you're going to spend some of your energy.
So what I wanted to do was kind of close out this example before Kate starts another one with the toner example, because the last step, again, is the improvement in reporting the findings. So for my example, what happened with the company, it was one of the decision factors, not the only one, but one of them, as they were looking at future designs for toner. So this whole process was based on a very conventional method, and we chose one. There's various types of toners, even within the conventional method, but we chose the largest volume, the most popular one, and did the LCA on that. And as a company, we're looking at future designs, this study was taken into account significantly. And as I mentioned before, because the energy usage in the machines was such a high impact, the next design, the next methodology of making toner really took that into consideration. So moving away from conventional methods to more chemical design, we can actually grow the toner particles, is something that company invested heavily into. And then in general, just knowing the value of, if we had not looked at the life cycle and we had just focused on that, again, our box, that toner manufacturing, and poured lots of money and resources in trying to reduce, solid waste by 5% more, it would have really had no impact on the overall life cycle, versus these types of significant changes in future designs that can really have a big impact. So,
okay. So moving on, I'm going to talk about software calculations, and I have another example that we'll walk through of LCA we did in the last couple months to a year. So software is used obviously to facilitate life cycle assessments because it can turn that inventory data into environmental impact. So it's really good for relatively quick comparisons or complex studies. I'm going to walk through a complex study, but in the end, we ended up using it kind of for some quick comparisons too. Imagine you're a product designer and you have your choice of a couple different plastics. Which one has the lowest environmental footprint? Well, you can go right into the software programs and you can play around with, here's the 3 different plastics, let's run them and see how they compare. The typical process, you collect kind of input-output data, so that same inventory, but then really there's embedded inventories, there's embedded data sets that you can choose to populate the energy, materials, waste associated with that. So for example, you have a product that has 5 grams of PVC, polyvinyl chloride, in it. You don't have to physically go out and collect, okay, how many pounds of chemical X go into making PVC and what are the exact air emissions from that. That's already populated in the data sets for you. Someone else has already done that work for you. So you can go in and you can pull from that. The different software tools that are available that are typically used are all listed there, so you can go online and read more about those. SEMA Pro is the one that we use, so that's kind of what I'll be talking through a little bit today. There's Gabby, Umberto. There's now some more web-based tools as well, so you can look at those and play around with those too. So the example I'm going to talk about is a LCA of 3 blood pressure cuff models that were designed and manufactured by Welch Allyn. Welch Allyn is located in Skaneateles, which is just west of Syracuse in New York. And we were looking at 3 disposable models only. So this is kind of an important point to make. So if we wanted to compare reusables, because we always get that question, why weren't you looking at reusable cuffs? Why was this only, disposables? That's the model, that's kind of the business model we're looking at in this case. If we were to compare a disposable versus a reusable, that's a totally different study. They're going to be used in different ways, as I'm sure you can imagine. A disposable cuff is going to be used in a hospital, in some other situation where you have high risk of contamination, high risk of disease, whereas your doctor's office may have a reusable cuff. And then there were really 2 main goals for doing this. They want to understand their product design decisions. They had a new cuff that was coming out that they said, we designed this to be environmentally friendly, but we really want you to validate that, and we want to see how these changes we made actually affected the impact. And then they want to communicate that to their customers as well. So kind of a brief overview, there were 3 different models that we evaluated of cuffs. Cuff A has 1 or 2 attached tube sets, so you can see it in the picture there. It's primarily made of PVC and nylon. Majority of it is PVC. Cuff B, Welch Allyn kind of designed this flex support, that's what they're calling it, eliminates the tube set. So that was a design decision they made way before they got involved with us, and not specifically for environmental reasons. Okay, so that was interesting too, to see how using that flex support does or doesn't impact the environmental impact. And it's made of some different plastics, and it weighs 15% less than Cuff A. Cuff C also uses that flex support. It's made of 100% polypropylene, so they totally switched the plastic that they're using. They eliminated a separate base material and loop. So if you've ever had your blood pressure taken, there's the big piece of Velcro, right? There's a piece of Velcro on each of the 2 halves that go around kind of the cuff when they're taking your blood pressure. So they were able to eliminate that one base material and the loop. Okay? And then because of all these changes, they got some significant weight reduction. So this case study, if you're interested in more details on what I'm presenting today, was presented at the 2011 LCA conference in Chicago as well. And you can follow up with us if you want, even more details. So the functional unit, so all of this goes into how you're defining the scope, how you're defining your functional unit. We looked at 200 cuffs, and they perform equally and perform the same function. Again, this is very critical. Early on we were asking Welch Allyn these questions. Do these cuffs, if I'm a hospital, am I more likely to buy one or the other cuffs for some performance reason? And the answer was no. You really swap out either cuff. They're used the same way. They perform exactly the same function. They're intended to be used in exactly the same way. That's how we were able to compare them. It's kind of the classic disposable paper cup versus a ceramic cup, or cloth diapers versus disposable diapers, right? And that's when you get into the whole functional unit conversation, because how can you really compare one to the other? You have to find a way to do that. We looked at landfill and incineration end-of-life options. So we modeled both of those. So 100% of the cuffs going to both of those. And we used Eco Indicator 99 to model the environmental impact. These are the system boundaries. So everything that was included in the actual LCA that we did, you'll notice that 2 processes are excluded. The customer, there's really no energy, there's nothing associated really with using the cuffs, right? Any energy to inflate them was allocated to whatever that inflation device is. So you could use something manual, you can manually pump up the cuffs, you can use some electronic piece of equipment, so we allocated that energy to that actual device. And then there's ink, right? So the cups say Welch Allyn and have a pretty logo on them. So that was eliminated or excluded from the boundary simply because it was such a small amount of ink. We didn't expect it to have, any real influence on the LCA, so we excluded it. So here's a summary of the results. The chart on the top kind of shows the 3 different cuffs and how the materials assembly is assembly energy at Welch Allyn, the cuff packaging, transport, landfill and incineration end of life kind of stages, and how the 3 cuffs compare. Now what that chart doesn't tell you is how the materials and assembly relate to each other, right? So we don't know if materials have more impact than assembly, etc. So I'll get into that in the next slide. And then the the chart on the bottom gets more into those midpoint indicators or the category indicators. So if you want to look even further, so fossil fuels, for example, well, the 3 cups are mainly made out of plastic. So it's not all that surprising that fossil fuels kind of jumps ahead, as being the major indicator. So then this slide, we took the materials, assembly, packaging, transport, and end of life again, and this is just looking at incineration, and identify, which processes, which portions of the life cycle contribute the most. Again, so Welch Allyn can now concentrate on those portions of the life cycle, right? So we found that cuff materials are the largest contributor, which was somewhat of a surprise, a little bit to us and to them. We thought end of life was going to have a much more significant contribution. When you really think about products like this that are disposable, that's the first thing you think about is, I don't want to have to throw that in the trash. That's a major factor. That's going to contribute a lot of impact. And it was somewhat surprising that it didn't. And I should say that although this is incineration end of life, the landfill end of life method really mimicked this. So it was very minimal as well. Assembly energy, also smallest contributor. So that's Welch Allyn's assembly energy, something they have under control, which was kind of good for them to know that too. You notice the packaging between the 3 cuffs goes down a lot. Well, they had made some packaging decisions as they improved the cuffs as well. So, for example, cuff A, I believe, is packaged, each cuff is packaged individually in a plastic bag. Well, cuff C is not. So they were able to eliminate some of that extra packaging, some things that they found were just extra. And then the dematerialization of cuffs B and C, so they have less material, you see that show up in the transport impacts as well. If you have less material to transport, right, you have less weight, then you're going to have less impacts from transportation. So now if you want to further look at how the design of the cuffs affects the impact of the materials, so this is only looking at the materials that actually go into the cuffs. So we took that kind of first bar graph, or the graph that was all the way to the left on the previous slide, and broke it down even further. So you can see how cuffs B and C, they eliminated that part D, so that was the tube set. Cuff C eliminated part B. They had some reductions in some others. So you can really get into the nitty-gritty of this stuff and actually see what the effect of a design decision you made really is. And then we can do the same thing with end of life. So this is only looking at the end of life, and again, it's normalized to cuff A and incineration of cuff A because that was the highest impact. So you can see how the design decisions for cuff C significantly reduce it. You can also see how incineration and landfill compare, right? So now can we make choices a little bit about, okay, if I have cuff A, well, looking at these results, it's a lot better environmentally to landfill cuff A than it is to incinerate it, right? Same thing for cuff B. Cuff C actually is the opposite, right, based on the materials that are in cuff C. So some conclusions from this, mass and material type chosen in the design phase. So the the materials that the designers were actually choosing can significantly affect the environmental impact. And then improvements in the mass and material choice can actually affect the impact more than the end-of-life management strategy, which was really kind of enlightening to everybody involved. There's some future work to recycle the green cuff or cuff C, could further reduce its impact. And then this is how Welch Allyn used the results. So some of this we kind of knew up front how the results would be used, but in the end it was kind of interesting to see how it panned out. You know, they used them internally really to validate some of the choices that their product designers had made, understand the influence of their manufacturing operations and of their packaging, because again, as I mentioned, they made some changes to that packaging, how that was affected. And then further identify more operations that contribute impact. So now, you know, you're constantly improving, right? Their designers now are already on to the next cuff. What's the next big thing we're going to do? Well, what areas should they be focusing on? So that really helped them with that. And then results were also used externally. So they were able to validate, support some environmental claims that they were making. They can educate their customers to make more informed purchasing decisions and end-of-life management decisions. You know, some other customers were asking, well, if we incinerate this cuff, is that really better? Is it worse? What should we be doing? How should we be promoting this, etc. So that's one way they can kind of communicate that. And then they found some additional benefits. They were able to kind of throughout the project, and especially at the end, educate internal employees and other departments that were not specifically involved in the LCA, but to at least let them know, hey, here's this tool we have, here's how it works, here's how to effectively communicate these results to people. You know, they obviously have a sales staff, so how should that sales staff be communicating the results? How do you do that effectively and correctly to communicate LCA results? And then through the inventory collection, so Welch Allyn, you know, went directly to suppliers to collect data about supplier operations. And it was very clear early on, you know, who was very dedicated to working with Welch, working through us to give us whatever data we needed, and who kind of backed away and wasn't really forthcoming with data. And that's a decision as a company to make. You know, do you want to continue to work with those suppliers? Are you feeling a little uneasy if they're not willing to give you data? Is that something you're okay with? Or do you want to, you know, kind of work through suppliers that you feel are committed to the cause as much as you are? So just to kind of wrap things up, you know, here are some challenges with any LCA that you do. You know, data collection is a big challenge. They're very complex supply chains, suppliers of suppliers of suppliers, and really how far back in the life cycle do you want to collect data? You know, that's always a question early on. And the analysis can be very time consuming if the data is not readily available. I mean, for example, you know, the last couple LCAs that we've done here at the Institute have taken between 6 months and a year. And that's because they're simply very data intense, they're very complex systems. And if you're going to do it right, you know, oftentimes it takes a good amount of time to do. It can be a challenge to engage suppliers and abuse processors to do data analysis, to collect data. How representative is the data that you have? Do you have data from 10 years ago? Well, obviously that's not the best data out there, but it might be the best that you have at the time. You know, so understanding that. Communicating results, again, can also be tricky. We've all seen things kind of manipulated, you know, when they're communicated. And comparative LCA results. So you're comparing one product to another. This is kind of my product is 50% better than your product, right? Those are usually based on a comparative LCA. So they do a full LCA of the two different product lines. They have the results, and then they want to say, I'm 50% better than you. Well, they're really representative of one specific case, and they don't represent the population of a product. I think sometimes some gets lost in translation of that. You know, because I've shown that one cup or one cuff is better than this other cuff doesn't mean that every single cuff that's out there, you know, is better than another one. or if you show that one product that's recycled at the end of life is better than one product that's landfilled at the end of life, doesn't mean every product, you know, is like that. Or if you do an LCA on one specific model of a product, you know, you're going to do a model of a laptop versus a model of a desktop. Well, that doesn't necessarily represent every single computer that's out there. It doesn't represent the whole population. And then lastly, some recommendations, you know, for performing LCAs. So educate, rally your team to understand LCA as a tool, reasons for its use. You know, that's really important up front. Understand how you can use it and understand the limitations of LCA. LCA is a great tool, but it does have a lot of limitations. You know, sometimes people get the results and they see, you know, again, I'm 50% better than you, and they think that's kind of the be-all, end-all. You know, that's the whole message to communicate, and really it's not. There's a lot of limitations when you communicate that. Clearly have your goal scope defined up front. I mean, this will come back to bite you if you don't. You'll find yourself a month in it and asking kind of these upfront questions that should have been defined early on. Same thing with a functional unit. You know, build your model with the best data that you have available. Perform sensitivity analyses. So did you make some assumptions? Well, let's test those assumptions. You know, did you assume something and then that's a huge contributor to your results? Well, then you need to go back and kind of do some sensitivity around that. Use experienced and trained LCA practitioners. I think that kind of goes without saying. Follow the ISO process. So ISO 1440, 1444. To validate marketing claims, it definitely brings recognition to the study. You know, if you're doing a comparative assertion, so again, that's the I'm 50% better than you, then you have to follow the ISO process. There's a peer review process to go through all that. It brings a lot of validity to your study and to your results. And then again, stay up to date on LCA research, data sources, modeling techniques. You know, this is an area that's always changing, always growing. So definitely stay up to date on what those new techniques are. So with that, I guess, Angela, if there's any questions?
Okay, anyone have any questions for Kate or Anahita? I have several questions. Is this webinar only on manufactured products? I think that was a...
Well, the products that Anahita and I both talked about are products that have been manufactured, that are definitely already complete. You know, if you're looking at something in the design phase, you know, so you don't totally have all this data yet, we've done a few projects like that. We didn't present them here today. And really, instead of doing kind of this full-blown ISO process, that might be beneficial to do more of a streamlined process. Like I talked about comparing, you know, different materials. If you have a product and you can use a couple different plastics to go in and kind of play with the data and look at how that would change. Or if you're deciding where do we want to have a manufacturing plant, you know, you can play around with transportation distances, or, you know, where you want to have a distribution center. You can do that too.
And the next question, will the slides be available after the webinar? They will be available on the NPPR website, p2.org. And I see a couple of hands raised a while ago. If you do have questions, please type those into the question box that GoToWebinar provides you with. It doesn't look like we're getting any new questions.
Okay, well, Kate and I are, you know, of course we're available. Our information is here, and we'd be happy to take follow-on questions after today. We just want to thank you for your time and for having us. We've enjoyed the webinar, and hopefully you gained some knowledge out of it.
Great. We have one question just come in real quick.
Okay.
Can you explain the pros and cons of the various softwares?
Well, that's it.
Well, that's a loaded question.
What we did a long time ago, just kind of start and taking that on, when we went to identify which software we wanted to, I did this for the company, and I think it was also done here at RIT. They are different, so it's important to do a benchmarking study to identify what's most important, what are you purchasing the software for, who's going to use it, what are the different components, what can it really give you in terms of results. So, you know, we can't get into all the nitty-gritty here, but if you were interested in taking a look at some of those options, if you could contact us afterwards, we can send you in the right direction, for sure.
Okay.
Are there any other questions coming in, Angela?
Yes. How about applying to building design process?
I'm sorry, Angela, could you say that again?
How about applying to building design process?
So using LCA maybe to support building design process. Any process or any product where you're going to compare materials or even processes, you can certainly use LCA to do that for you, to help you to do that. You know, you want to compare using, I don't know, MDF and plywood and something else, right? You can go in and you can kind of play around in some of the software tools, and you can certainly use that. You know, same thing for different types of flooring or different types of, you know, whatever, you can compare them.
Okay, the next question, how is LCA different from Eco LCA, and what is the best one to be used?
It would be great to have the conversation. I'm not exactly sure what you mean by the Eco LCA.
Yeah, so whoever asked that question, we'd love to talk with you about it, but we're not familiar with Eco LCA.
We'll see if they type something in. How many man hours to do one of these?
That's a loaded question, and I say that's a loaded question because it depends a lot. For example, the Welch Allen case study that I talked through was one of the lower end of the man hours simply because working with Welch Allen was great. Their people were very dedicated, very timely, got us information, you know, as soon as we asked for it. Their suppliers were great in the same respect. We've had other companies where it can take you, you know, 3 months to collect one data point, and it's kind of this going back and forth to collect data. So it really depends a lot on the team of people that you have kind of working on the LCA. And then, of course, the scope and how complex the system is. If you're going to do an LCA of a product with 5 parts, it's a lot different than a product with 100. Mm-hmm. You know, just simply the volume of time it takes to model all that and collect all the data and sort through it all varies a lot. So I know I didn't give you a straight answer, but it really does vary significantly.
The person who asked the question, how LCA is different from Eco LCA, messaged ecologically based LCA. Does that help clarify that?
It's something that we would have to discuss offline. I think it would be great to have the conversation if that person wouldn't mind contacting myself or Kate afterwards.
Okay. And one more question. In the cancer cases listed under the indicator steps of the process, were worker cancer cases taken into account? Was worker health and safety otherwise taken into account in any part of the human health assessment?
That's going to vary depending on the impact assessment method that you choose, right? Some impact assessment methods definitely take that into consideration, and some do not. To be perfectly honest, I would myself have to go back and kind of pull some of that data and look and see exactly how worker health and safety and kind of cancer cases, or really any worker health and safety, how that's incorporated into some of the impact assessment methods. You know, to what detail it's incorporated in there. That's a good question.
And if you could email Kate directly, we could get back to you.
Thank you, Anahita and Kate, for a wonderful webinar. That is it for the questions that have come in.
Thanks,
Okay.
Angela.
So if anybody has any more questions, feel free to email or call us.
We just want to remind folks to help us complete the survey, and also for thanks very much for taking the time to both of our speakers for preparing and delivering this webinar, as well as to our attendees, all the attendees for being present. Also, be sure to register for the April 3rd green screen webinar coming up, and take a look at the website that is p2.org/challenge for more information on the Safer Chemistry Challenge program, or if you're interested in possibly in joining. And you can also contact us with any questions at saferchemistry@gmail.com. Thanks again.